Hello, my name is Andrew Levy, and I'm a program manager at AlphaCore. We are a Tempe, Arizona-based company that specializes in robust, high-performance microelectronics. AlphaCore's solution to the AFWERX Microelectronics Challenge is a new type of lidar receiver that enables an unprecedented degree of flexibility and capability for autonomous vehicle operation. As you know, lidar is a widely used laser-based imaging system for generating three-dimensional images of the world around it. Typical lidar applications are automotive, UAVs, and other systems to detect and measure moving objects and draw 3D maps of terrain and human construction. We will develop, build, test, and supply a highly integrated type of integrated circuit called a digital readout IC, or DROIC, that is paired with an array of detectors that are able to sense the reflected returns from the laser. This array forms a focal plane which can be digitally controlled to sense signals from a wide volume around it, and the laser returns provide information about what is causing the laser reflections. Complex computer algorithms are then used to process the return data in real time to form an image that not only renders the object in three dimensions, but can also indicate object velocity, direction, and distance relative to the lidar system. All this adds up to being able to detect and monitor nearby objects to feed a vehicle's navigation and control system so that the vehicle can autonomously approach or avoid certain objects or take other actions, depending on the situation, what is known about the nearby object, and the mission of the autonomous vehicle. As I said, lidar is quite commonly used. In fact, AlphaCore has been in the readout IC business for quite a while now. We have been developing readout chips for both missile defense applications and detecting infinitesimal particles produced inside massive experimental particle accelerators. What makes this DROIC different? Most lidar systems today employ a rotating mechanical laser/sensing system. Our solid-state focal plane array is smaller, lighter, faster, and more reliable. We'll also be taking advantage of the ability to squeeze incredible imaging and processing capability into a single pixel, and then able to increase the number of pixels in a single chip by many thousand times because of the 14 nanometer fabrication process available to us through the AFWERX Microelectronic Challenge. All this, in turn, enables other new architectural features in our proposed digital ROIC. The DROIC will support wider dynamic range, faster response, new programmable modes of operation, and other features previously not feasible in such a small volume and with such low power. Part of our secret sauce for our project is not really a secret at all. We have very strong partners in both industry and academia to help us in our efforts. In addition to 6 PhDs and 7 graduate students from Arizona State University, our neighbor here in Tempe, we are already working with leading companies in this technology, such as Boeing Spectralab and Raytheon Vision Systems for detector arrays, and the Sensel division of ON Semiconductor. AlphaCore's own team includes 4 PhDs in optics, advanced analog electronics, and built-in self-test, and a portfolio of over 100 patents generated by AlphaCore's team of researchers and engineers. We not only have a distinguished pedigree in development of state-of-the-art readout circuits, as mentioned earlier, but also for creating other groundbreaking analog, mixed signal, and radio frequency designs. An important component of this challenge is to assure the integrity and security of the products that flow from it. AlphaCore currently has U.S. Air Force contracts to develop 2 unique methods of authentication and identification for different types of microelectronics. AlphaCore plans to embed these innovative hardware security mechanisms to augment more traditional methods. And of course, we will take advantage of the additional security afforded by the trusted foundry flow supported by the DoD. The bottom line is that our 14 nanometer chip, when embedded in a full lidar system, will form an integral part of an autonomous vehicle control system. It will help prevent crashes like these trains and this automobile and this drones. However, it will be a while before it helps with this, galaxies colliding. AlphaCore thanks you for watching our video, and please remember to like us. That's all.